Good morning. Welcome back to Math and Engineering Help Desk. I hope that you are having a magnificent Monday. Today's video is about systems of equations. We're going to be examining how to solve systems of equations using the substitution method. I'll be using three separate, relatively simple examples to kind of illustrate what to do. Obviously, with certain systems, the substitution method may prove difficult due to values that you might get, but the ones that, obviously there are other methods that you can use, elimination and graphing, of course, included, but we'll be using the substitution method to solve, and we'll use the graphing methods to check our solutions today. So here's the format we're going to follow. We're going to rewrite one equation in terms of one of the variables if we have to. We're going to substitute that equation into the other equation for the variable, solve for the second variable, and then substitute the value we get from the second variable into the equation from step one. That way we can find the first variable, and then we of course check the solution by either substituting the values back into the original system or graphing the system, or both. Obviously, if we can verify using both methods, it's a pretty much guarantee that we'll get it accurately as necessary. So let's go ahead and solve the first system right now. Okay, so here's our first system. Let's blow this up a little bit, make this a little bigger, making sure it work. Okay, so our first system is j equals 2k and j plus 3k equals 5. So this is an example of a system where we have a variable already written in terms of, so in this case the variable j is already solved as a number by itself, and it equals to 2k. So what we're going to do is we're going to take this second equation, and if we see a j, we're going to replace it with 2k, which is how we get the substitution method in the first place. So in this case, 2k plus 3k equals 5. Right, so since 2k plus 3k equals 5, obviously there's nothing to do with the 2k. We drop the parentheses, and it'll be 2k plus 3k equals 5. We combine our like terms, 2k plus 3k equals 5k, so that means 5k equals 5, and if I divide both sides by 5, I'll get k equals 1. So since k equals 1, that would be our first variable, right? So that is our first solution that we need in this case. And then when we go back up here, we're going to need to plug in this k value into this k right here. So that means that j is just going to equal 2 times 1, which is just 2. So our solution here, if we were to write it in the format of j comma k, is 2 comma 1. Okay, obviously we would write ordered pairs in alphabetical order. So 2 comma 1 would be our solution here. And that would be j comma k, right? Okay. Now let's check the solution with our graph. So I've got Desmos up right here. I already have the equations in the next few variables, next few equations as well. But if we look and turn these two equations on, obviously I used y and x for Desmos. So I can already tell right now if I should have written x equals 2y, but that's okay. We can just switch those around. But notice that the solution here, and nice thing is when we plug in Desmos, when we plug in things to Desmos, it'll give us the intersection points. It'll also give us intercepts if we click on the line. So if I click on the blue line, it'll give me the x and y intercepts for that. If I click on the red line, it'll give me the x, in this case the x and y intercepts are both 0, 0. But more importantly, it'll give us this ordered pair. Now because I morphed the equations, I should have written x equals 2y, which I can do right here just to kind of fix that up. And then I can write 3x plus y, 3y plus, whoops, 3y plus x equals 5. And then that, of course, would reflect that solution that we're looking for, which is 2 comma 1. Okay, so we checked it with graphing. And then, of course, if I was to plug both of these numbers in, they should work in both equations. So we'll do that real quick. Does 2 equal 2 times 1? Yes, it does. And if I do 2 plus 3 times 1, does that equal 5? Yes, it does. So this is a big check. So the solution of 2 comma 1 is correct. Okay, next system we have here is one that needs a little bit of rewriting. So we've got 6x plus 4y equals 38, and x plus y equals 5. Now, when we're doing substitution method, generally speaking, you want to solve the equation that is a little easier or written in smaller terms to solve. So while we could solve 6x minus 4y for x or y and then plug it into the second equation, I think you'll agree with me that x plus y equals 5 is a much simpler equation to try to solve for one of the variables. So we're going to do that first, and just to prove it to you, I'll do the other way as well, just to show you that no matter which way you decide to do it, obviously one will be harder than the other, but you should arrive at the same solution regardless of which one you choose. Okay, so we'll take the x plus y equals 5. Let's solve that for y. So if I want to solve that for y, I have to just move this x term over to the other side. Okay, using the mouse again here. So that means that y equals 5 minus x, which is fine. You can write it like that. You can write negative x plus 5 if you want, but that would be this equation rewritten in terms of y, which makes sense, because if I wanted to know what y was, let's say x was 3 and y was 2, then all I have to do is here is subtract 3 from 5 to get the fact that y equals 2. So that makes sense that y equals 5 minus x. So now what we do is we take this first equation right here, this that we solved for y, and we're going to plug it into the first equation that's in the system. Always make sure that when you solve one equation, you got to use the other equation to make your substitution. A very common mistake is to make the substitution into the same equation, and you'll just end up with an identity if you do that. So don't do that. All right, so let's go ahead and plug in for the second equation. So 6x minus 4. Now here's a y, so we're going to write 5 minus x in parentheses equals 38. So also be careful of that. Make sure that when you're plugging in all the terms that are made in that variable. That way you will arrive at an accurate equation. Now notice that this time we have to do a little distribution to simplify this. So 6x minus 20 plus 4x, because multiplying, think of it as multiplying negative 4 into this, right? That will equal 38. Okay? So now we'll combine our like terms. 6x and 4x are like terms. That becomes 10x minus 20 equals 38. And then let's solve our system. So adding 20 on both sides will give us 10x equals 58, which means that x will equal 5.8. Okay? So if x equals 5.8, we're going to go to our original equation, x plus y equals 5, and we're going to plug in 5.8 plus y equals 5. We also could, of course, plug into y equals 5 minus 5.8. Either of these equations would work for your system. And actually, you could take the 5.8 and plug it into this equation and solve for y, but once again, which one's easier for you to work with? So in this case, we'll use x plus y equals 5, or its derivative of y equals 5 minus 5.8. So since x equals 5.8, y equals 5 minus 5.8, which means that y equals negative 0.8. Okay, so there's our solution. So we would write our solution as an ordered pair. Our solution is 5.8, comma, negative 0.8. Okay, so let's go ahead and go to our system. Let's turn off the previous example. So here's our first example, and here's our second example. So notice here's the intersection right over here. So we're looking to see that that is 5.8 and negative 0.8, and sure enough, there it is, right? So we highlight the solution, 5.8, negative 0.8. Our graph reflects that this is the correct solution. So we could stop there if we want to, but let's just make sure that it works. And we'll also solve this system using substitution the other way. We could also plug these numbers in to both of these equations, and of course it would work for both of these. Now, just to show you that if we were to solve this system here, 6x minus 4y equals 38, solve that for y first, we will still arrive at a correct solution, although of course you'll see what happens. The terms are going to be a little bit difficult to handle. So 6x minus 4y equals 38. If we're going to solve this for y, we're going to subtract 6x first, so it's going to be negative 4y equals 38 minus 6x. Now when I divide by negative 4 on both sides, we're going to get y equals negative 9.5 plus 1.5x, 3 over 2x if you prefer, right? So just to make sure, 38 divided by negative 4, negative 9.5, and then, yep, so it's 1.5x. Okay, so that y is now solved, and now we're going to go to the second equation, and we're going to make a substitution for that y. So x plus negative 9.5 plus 1.5x equals 5, right? So once again, you see how this is now a decimally equation, kind of tricky, but 2.5x minus 9.5 will equal 5. That means that when we add 9.5 to both sides, we'll get 2.5x equals 14.5. And then by dividing 14.5 by 2.5, we will get 5.8 for x. So see, we'll still get the right answer. And of course, if I go back to my original equation and take 5.8 and plug this in, that's going to be 6 times 5.8. Actually, I'll use the y version. Negative 9.5, excuse me, plus 1.5 times 5.8. Does that equal negative 0.8? So once again, we just do 1.5 times 5.8, and that's going to be 8.7. Negative 9.5 plus 8.7 would simplify to y equals negative 0.8. So see, we still arrive at the same solution when we solve it one way or the other, but you can agree with me that solving this equation for the variable and then making the substitution here made us only have decimals when we got to the solution, whereas here we had decimals right away, and we had to work very carefully to make sure that we arrived at the same answer. So while it would work, it certainly behooves you to choose an easier equation to solve for that variable, solve for a variable. Okay, now let's do a word problem just to kind of make sure we're thinking of word problems and systems, and this is one of the more difficult kind of things to do in writing a system from a word problem. So do just take time here to kind of think about what are the variables and ways that you can express those variables in two separate equations. So here we have the problem. A serving of rice contains 251 calories, and a serving of beans contains 227 calories. How many servings of rice and how many servings of beans will provide a total of 2,187 calories if the person eats twice as many servings of rice per day as beans? Okay, so here we have variables. Let's define these variables. Let's let x equal the servings of rice, because that's the unknown, and one of the unknowns, and let's y equal the servings of beans. Okay, it's a lot of carbs, by the way, some, in the rice at least. All right, so and that's a lot of calories per day too if you're eating just rice and beans. But anyway, I digress. Servings of rice, servings of beans. Okay, so those are our variables, and let's think about what kinds of equations we can write for this. Now, how would we calculate the calories that we would be eating from per serving here? So if we're told that 251 calories is per serving of rice and 227 calories as servings of beans, and we want to get a total of 2,187 calories, the way that we can express this is if we take the amount of servings of rice we'd eat and multiply by 251, and then add 227 times the servings of beans, that total amount of calories would be 2,187. So once again, that's a really messed up equation, but it is what it is. The other way that we can express or come up with an equation is an understanding of the relationship between the amount of beans, servings of beans and servings of rice. It says here that we're going to have twice as many servings of rice as servings of beans. So that means that if I think about my servings of rice, twice that would equal my, twice the beans, excuse me, would be my rice. Or, yeah, that makes sense. Okay, so twice as many servings of rice per day as beans. So 2 times y equals x. So I'm going to make one change right here. Just I realized that I used the wrong thing. Okay, so back to that. Okay, so that's the system that we're going to use and try to figure out what x and y are. Now, based on the word problem, we already have one variable that's already solved for. In this case, it's x. X equals 2y. So since we have that already solved for, let's plug this in to the first equation, and wherever we see an x. So instead of 251x, we're going to do 251 times 2y plus 227y equals 2,187. So 251 times 2y is 502y plus 227y equals 2187. So combine those like terms, that's going to be 729y equals 2187. And if I divide both sides by that, I'm pretty sure it's going to be 3, but I'm going to use my calculator just to make sure, and then it is indeed 3. So y would equal 3 here. Okay. Now, if y equals 3, then we come back up here and we'll say, well, how many servings of rice would we get? Well, 2 times 3 equals 6. So, so x would equal 6 here. Okay. Now, our solution, therefore, would be 6, 3. Okay, so even though our equation looks kind of ridiculous, the solution to the system is a little bit more practical, 6, 3. So this would fit in a standard window if we were to graph these two things. Now, you'll notice that so far, when I've been using Desmos to check my calculations, I've been able to type in pretty much exactly what the equation is without having to solve it into y equals form. So that's one of the benefits of using Desmos over a graphing calculator. So if you have that power, definitely do that. All right, so let's put our systems up on the graph. And here's the two equations, 2y equals x, which is a proportional relationship because there's no c value. And then here's our 251x plus 227y equals 2,187. So our intersection is already highlighted, and our intersection is 6, 3. So again, our graph verifies our substitution solution of 6, 3. And of course, another way to check it would be to plug in the original 6 and 3 into 251 and 227 to make sure we get 2,187. That would also work. So there's a brief overview of how to solve systems using substitution and checking it with our graph. So ultimately, we'll have a total of 3 things. The next video will be about elimination, but for now, we got substitution, we have graphing to check, and we have substitution of the solutions into the original equations to check to verify to make sure we are correct as well. So I hope you enjoyed this video. If you did, please hit that like button. Give us a subscription. We, as mentioned in the past few videos, we've already crossed 500 subscribers. We're already on our way to 1,000, and I love bringing these kinds of videos to you to help out with your mathematics, your algebra, and even past videos, your engineering. All right, so I hope you have a wonderful day, and don't forget to be awesome.